All right, so now we are going to be talking about a geometric sequence. Having an understanding of ratios, which we talked about in our last video, is going to be helpful. But if you don't, that's okay. We can still talk about this without a super strong understanding of ratios. So if you're still kind of shaky, don't worry. This will help us get you there, though. This will help you practice your ratios as well. So a geometric sequence, sometimes also called a geometric series, is just going to be a sequence where a number is continually multiplied by the same number. So what does that mean? Let's say we're going to choose, let's go ahead and do a series. We'll do an example here. Make a series starting at 1 that increases by we'll just say increases by 2 each time. There, simple enough. Let me go ahead and start this out. Okay, so our key here, right? We said by 2. Here's our 2. There are times 2. So if I started with 1, like I said I did, so we'd go 1, and then that's going to be multiplied by 2, so that goes to 2. And then 2 is going to be multiplied by 2, and that goes to 4. 4 is now multiplied by 2, that goes to 8. 8 is multiplied by 2, that goes to 16. 16 multiplied by 2 is 32. 32 times 2 is 64, and then 128, and so on, right? And just as a little reminder there, right, if we put in small numbers, each one is getting increased by 2. Let's make this a little smaller. So times 2, right? And so on and so forth. It's just the last number is getting increased by 2. Now, each one of these little spots, we have a name for these. Let me use let's use orange. I like orange a lot. Each one of these spots is called a term. And a term is just like an amount, or like the number of the thing. So what we have, the 1 would be the first term, this 2 would be the second term, the 4 would be the third term, the 8th would be the fourth term, and so on, right? It's just which number in the sequence it is, or which amount in the sequence it is. Now, another way you could think about this is that the ratio we used, or the way we multiplied it, was not necessarily by 2, but rather by a ratio of 2 to 1, or 2 over 1, right? If there was, in fact, a 1 on bottom, like every number is secretly just over 1, right, then we could have just, all of these are going 2, and then, 2 by 1, and then 2 by 1, and then 2 by 1, and 2 by 1, but the 1 is staying the same the whole time. But what if we did a fraction, right? We can do a geometric sequence by doing a fraction. So let's go ahead and start a new sequence, and we'll say this new example over here, example 2, make a sequence that reduces by, we'll do 1/3. 1/3 is kind of fun. So our first number in the term, let's go ahead and just start. I'm making the sequence here. You're often going to be given a problem, and it's going to ask you to figure out what the sequence is. But for here, let's go ahead and just make our own. So let's say 900. Let's have that as our first number. And then, so the next, what we would do is we would find, well, what's 1/3 of 900? Okay, if this will just let me increase it. There we go. Well, 1/3 of 900 is going to be 300. And then 1/3 of 300 would be 100. And then 1/3 of 100 would be, it's going to be kind of ugly here, but 33.333 repeating. And then so on and so forth, right? We could go on and on and on and on and on. But each one is divided by, I would say, 1/3, comma 1/3, 1/3, 1/3, and so on. Okay? It's just about sticking and starting with one ratio and doing that over and over and over again, whether that's multiplying it by a certain factor or increasing it by a certain factor. Okay, that's it. Not nearly as complicated. It's just kind of about looking for the pattern, looking for just how much is being changed in each direction, and making a ratio for it. It's going to be key if you're going smaller, right, to see that, oh, that's going to be a fraction. And so what's that fraction? How much is it shrinking by? And if you're not sure, always start by just looking at, say, the first two numbers in a series and try and figure out, well, how much smaller is this than this, right? Or how much bigger is this than, this 2 than this 1? Because it's going to be the same each time, so if you can figure out what's just the difference in between one jump, then you know that's going to be the same with every jump after that. All right. I hope that helps you out, and I will see you next time.